Assalamualaikum. My name is Aisha Akhtar. Now I'm going to present a paper presentation whose name is Cost Efficient Resource Management in Fog Computing Supported Medical Cyber Physical System. First, you have to know about the cost efficient resource management, fog computing, as well as the medical cyber physical system. What's that? So first one, the term resource efficiency refers to the use of the earth limited resource in a sustainable manner while minimizing the environmental repercussions. Then the fog computing refers to a dispersed computer structure positioning between the cloud and the data producing devices. Last one, MCPS. MCPS integrates the medical devices including both monitoring devices and delivery devices with the software application. Then the abstract part. So in this paper, I have included some abstraction uh, part which have the number one as a growing healthcare and trained medical cyber physical systems to support MCPS cloud resource as well as to combat this issue computation resource onto the network is 4 in particular investigate base station association task distribution and virtual machine placement. 5 to address the computation complexity linear programming based two-phase heuristic algorithm. 6 extensive experiment result greedy algorithm. Now the introduction part, main contribution. So there are some few contribution which is included in this paper. Number one, the FC that means the fog computing MCPS a process by incorporating fog computing into the MCPS to host VMD application. They focus on a cost-effective resource management problem with guarantee QoS, that means quality of service in FC MCPS. Number two, formatted the cost of minimization problem. Number three, the high computational complexity of the solving MINLP. Now the motivation part. So in this paper, there have motivation part, that is the attempt to reduce total unit cost, which includes total VM, that means virtual machine deployment cost, uploading cost, and the inter BS, that means base station communication cost. To illustrate the motivation of their work, let us first consider a toy example in figure 2. There are base 1, base 1 to base 7, and 3 users with 3 different applications. All the users are within the transmission range of BS2 and the BS6 with the uplink cost of 2 and 1 respectively. User 1 is also in the transmission range of BS1 with the uplink cost of 1. For each BS, they assume there are 3 subcarriers. Each subcarrier can contribute an uploading data rate of 1 per time unit. Generally, the communication cost between each pair, this example, they can also see that a better solution of BS association, subcarrier allocation, virtual machine deployment, and task distribution not only contribution to lower total cost but also improve the quality of service of applications. Then the section 3, what's that? That is the system model and the problem statement. There have few subsection. 3.1 network model. So they consider a connected cellular network. So here there have some categories or some variables that including in this table. Now the problem statement. Their objective is to minimize the overall unit cost for deploying for FC MCPS in a given base station infrastructure to guarantee the required quality of service of all applications from the users. On the other hand, placing all the VM in the associate base helps reduce the inter-VS communication cost, but it is not efficient since the VM deployment cost of the associate BS might be significantly higher and therefore is not ignorable. So next section is problem formulations. There have few subsections. The first one is user association constant. They first define binary variable to denote whether user is associated with base station or not. Then next, task distribution constants. As shown in their toy example, all data uploaded at BS2 are either processed locally or distributed to the other BS. Number 3, virtual machine placement constant. A BS can process medical data stream of application is deployment on it. using scaling factor to indicate the relationship between processing speed and allocate computation resource. Number 4, quality of service constant. So according to the data analysis produced in MCPS, the medical sensing data shall go through three stages. Number 1 stage uploading to the user associate BS, which is considered J, transferring from J to processing BS K, and the processing at K. They all influence over the overall delay and hence the quality of service. Number 5, that means subsection 5. So an MINLP formulation, when the subcarriers are exclusively allocated to a user, the uplink cost is determined by the uplink rate regardless of the data volume. On the other hand, the inter-VS communication cost is determined by the actual network traffic. Number 6, linearization. It is the important part in this paper. It is difficult to solve the MINLP problem directly due to its high computational complexity. Fortunately, they noticed that 21 sections to 21 equations is a cubic inequations. The two cubic terms are products of two binary variable and one floating point variable. It is possible to linearize term to lower the computation complexity. To this end, they first define a new auxiliary variable. Their MINLP problem can be linearized into a mixed integer linear program below. Important part of this paper or important section in this paper, algorithm design, optimal programming model, phase heuristic algorithm. There have some categories or subsections. 5.1, uplink communication cost minimization. To obtain the optimal user association solutions towards minimum uplink communication cost without the consideration of task distribution. So in this case, they only need to consider user association. Next, joint optimization to find out the task distribution and the VM deployment solution with the minimize both inter base station communication cost and the virtual machine deployment cost. Number 3, two-phase linear programming based heuristic algorithm. So in this section, they represent their two-phase linear programming based heuristic algorithm based on the above two sub problem formulation. Algorithm 1 is a brief summary of the algorithm. In the first phase, they attempt to determine the user association with the lowest uplink communication cost. To that end, they first relax all of the binaries in MILP uplink and then solve the LP, that means linear programming uplink problem that result. Based on the above two subproblem formulations, they present their two-phase linear formulation-based heuristic algorithm in these sections. Algorithm 1 is a synapse of the algorithms. During the first phase, they try to find the user associated with the lowest uplink communication cost. To that end, they first relax the binary communication. The time complexity of algorithm 1 is polynomial. Clearly, all of the loops in algorithm 1 have a finite number of iterations. While only the LP problem is involved in each iteration, it will know that they obtain the optimal solution to the LP problem in polynomial time. As a result, the entire algorithm can be solved in the polynomial time. Section 7, related work. There are some subsections: medical cyber physical system, the developing trends in MCPS, including increased reliance on software to deliver new functionality, wider use of network connectivity in the MCPS, demand for continuous patients monitoring, and new opportunities for research and development. Second is Scholar Big Data Presenting Framework of the MCP for the MCPS. Number 2, base station association, BS energy saving, the dynamic of mobility, wireless network product, a predictive association game, and consensus protocols. Number 3, fog computing, website performance, network function, virtualization, peer-to-peer, IoT, that means Internet of Things, and the OPSIT project. And the last section is conclusions. The main work thing is this paper, base station, task distribution, and the VM deployment, which are all critical. These three issues towards minimizing the overall cost while satisfying the quality of service requirements and the problem is first formulated into on into and the MINLP problem. Also, they had the linearized it into on MILP problem and proposed a two phase LP problem heuristic algorithm. Thank you so much.